Hi everyone, I've had a couple of emails about exercise 8D questions 2, 3 and 4, so I'm going to go through them today in this video. Okay, so question 2. Velocity of car is given by v equals 12i minus 10j, and I always quite like to write them as column vectors, horizontal and vertical, and then I'm just going to draw this so we've got sort of a visual idea of what's going on. Okay, so let's try that again. So 12 in the positive horizontal direction and negative 10 in the vertical direction. So that is 10, but it's going downwards. So I'm doing that and that. And so my resultant velocity is this vector in that direction. Okay. So it wants us to find the speed of the car, and the speed basically is the magnitude of this vector. So this is my velocity vector, which has got a direction. If I just want the speed, then I just want basically the size of this vector. So it's going to be a bit of Pythagoras. So the speed is going to be the magnitude of the velocity vector, and we can use these two straight lines to indicate magnitude. So that's going to be Pythagoras square root of 10 squared plus 12 squared. 12 squared plus 10 squared. So that's going to give me 2 root 61, 15.620, so 15.6 meters per second to 3SF. Okay. So that's part A done. Part B then, the same situation. So 12 in the positive x direction, minus 10, so 10 in the negative y direction. That's what's happening. I've got my vector v here. I know the length of this now, and I'm going to use the exact value. They want to know the angle, the direction of motion. So the direction of motion is this, because this is what is actually happening, starting here and finishing here. So I'm going in this direction. The angle it makes with the vector I. So I, don't forget, is the unit vector in the x direction, positive x direction. So that's that vector. So I want this angle. And don't worry now that this is minus 10, because we've taken that into account with our arrow here showing that it goes positive across, negative down. Actually, as a right angle triangle, though, if I'm working out this angle, I need to draw it out because I just want the 12 and the 10. I don't want the negative 10 in my calculation. So let's do this. So tan of theta is opposite over adjacent. So theta is going to be inverse tan. 10 over 12. So that's going to give me 39.805, etc. So 39.8 degrees to 3SF. And that's that angle there. That's below vector I. Okay, so that's our first question done. Well, it's question 2 actually, but the first one I had an email about. Let's look at question 3. So question 3 now, similar idea, but acceleration this time. So our acceleration is given 3 in the positive x direction and then negative 4, so 4 downwards in the y direction. Same idea, magnitude of the acceleration. So I'm going to draw this 3 across as a vector, 4 down. So really similar question to before. And then this is my resulting acceleration vector. Magnitude of the acceleration, so the length of this, the size of this. So the magnitude of the acceleration, bit of Pythagoras again, nice 3, 4, 5 triangle. So that's going to be 5 meters per second squared for acceleration. Okay, and part B, the angle, the direction of the acceleration vector makes with unit vector j, and j, don't forget now, is the unit vector in the positive y direction. So let's just draw this diagram out again. So I've got 3, 4, my acceleration vector in that direction, and I want to know what angle does it make with the positive unit vector j. So with this unit vector, so my angle now that I'm looking for is going to be this whole angle here. Okay, so what I'm going to work out here, I'm going to work out this angle, and I'm just going to add that to 90 degrees. So let's look at my triangle. So again, this angle here, tan theta is 3/4. So another inverse tan question. .869698. So the angle that I want, the angle with that vector j is this whole thing, so it's going to be this theta plus my 90 degrees here. So that's going to give me, let me just add 90 to my answer here, 126.869. So 127 degrees to 3SF. Okay. And once you get the hang of these, they're very similar. So that question 3 is very similar to question 2. A little bit more tricky here, just making sure you know what the question means and remembering what those unit vectors are. Okay. Last one in this exercise that I've been asked about then. So question 4. A girl cycles from A to B and then from B to C. So her overall displacement, she started here, gone to B, gone to C. Her overall displacement is just this vector. Okay, so it doesn't matter what distance she's travelled here. If we're talking about displacement, which is a vector, she's ended up just doing this. Okay, it's a bit like, I suppose, if you got the train from, I don't know, Liverpool to Manchester and then Manchester to Sheffield, the overall journey that you've made is Liverpool to Sheffield. It doesn't matter how many times you've had to change train. Anyway, it tells us a bit of information about these vectors and it puts it on the diagram as well. And it wants us to find, first of all, the magnitude of this displacement from A to C. So I need to know, to find the length of that vector, the size of that vector, I need to know what that vector is. And AC, to go from A to C, I'm going from A to B in the positive direction, following the arrow, and then I'm going from B to C. So again, adding that on. So AB is this vector 10, 3. BC is this vector -7, 12. So that's going to give me 3 in the x direction, 3i, and then 15 in the y direction, 15j. So there's my vector AC, but I want the magnitude, so I want to find out the magnitude of this, the size of that vector, the length, bit of Pythagoras. Let's just get our calculator going. Square root of 3 squared plus 15 squared, 3 root 26, 15.297, so 15.3 kilometres this time to 3SF. Okay, let's have a look at part B. I'm just going to move that up slightly. Part B then. The total distance the girl has cycled to get from A to C. So the total distance she's travelled is going to be this distance plus this distance. So my total distance here is not my displacement. My displacement is, I've started here and finished here. So I've ended up 15.3 kilometres from home, but I've travelled more than 15.3 kilometres as a distance because I've gone from here to here, from here to here. So this is the displacement, 15.3, but my distance is going to be this journey. So it's that difference between displacement and distance that you need to get your head around. So my total distance here is going to be the magnitude of vector AB plus the magnitude of vector BC. This distance plus this distance. Okay, and AB then, is this vector 10, 3, so 10 across, 3 up. Bit of Pythagoras here. And BC, this vector, is 7 across in the negative x direction and 12 up. Clearly not drawn to scale, but there we go. And again, a bit of Pythagoras, 7 squared and 12 squared. calculators out. So 10 squared plus 3 squared in the first one, and then separately 7 squared plus 12 squared for the second one. And that's going to give me 24.3327. So 24.3 kilometres to 3SF. So my distance travelled is definitely different to my overall displacement, and that's an important distinction to make there. Okay. The next one is about the angle AC. So this vector AC we're looking at, this vector here, makes with the unit vector. So I'm just going to move this up. So AC, I've already worked that out. That's my vector 315, 3i plus 15j. So let's have a think about what that looks like. So that's going to look like 3 in the positive I direction, 15 in the positive j direction. So there's my overall vector AC. And I want to know the angle that AC makes with the unit vector I. And again, don't forget, I is just that unit vector in the positive x direction. So I want to know what this angle here is. Okay, so a little bit of trig, tan theta, 15 over 3. So theta inverse tan. And that's going to give me 78.69. So 78.7 degrees to 3SF. Okay, so I hope that's helped. That's 3 questions from exercise 8D, and then we're going to move on to the next mechanics chapter.